Hello there, and welcome to the Sleepless Scientist, a quiet place in the cosmos where your thoughts can unwind and knowledge becomes a soft lullaby for the night. Tonight's journey will take us into something both familiar and deeply mysterious, light itself, and a question that seems simple at first, but slowly unfolds into something much stranger. But before you settle in and get cozy, I'd love if you could take a moment to like this video and subscribe, only if you truly find these quiet explorations enjoyable. And when you're ready, leave a comment to let me know where in the world you're listening from and what time it is for you right now. It's always such a joy to see all the places we gather from, each in our own little slice of time. Now feel free to dim the lights, maybe turn on a fan for a soft background hum, and let's gently begin our journey into the nature of light together. And if your mind begins to wander, that's perfectly fine. Let it drift. We'll still be here, quietly unfolding the story. Tonight, we're going to follow a single photon, not a beam of light, not a glow across the sky, just one tiny piece of light, so small it has no size you could hold, no weight you could feel, and no shape you could see, and yet it carries energy, it carries momentum, and most quietly of all, it carries a story. This photon was born long ago, in a universe that looked nothing like the one you know, before there were stars, before there were galaxies, before there were planets, oceans, or eyes to see anything at all. It began its existence in a moment when the universe first became clear enough for light to move freely. And from that moment, it began what we would call a journey. It travelled across the expanding universe. It passed through darkness so vast it would take millions of years for anything else to change. It drifted between forming galaxies, curved gently around massive structures, and continued on uninterrupted for nearly 14 billion years, and eventually it arrived. Perhaps it reached a telescope orbiting Earth. Perhaps it touched a mirror, or a sensor, or even the delicate cells in a human eye. And in that instant its journey ended. Its energy was transferred, its presence vanished, and all that remained was the trace of where it had been. From our point of view, this is a story of incredible patience, a journey that took almost the entire age of the universe to complete, a traveller crossing unimaginable distance, moving steadily through time. But here is where the story begins to shift, because from the photon's own side, if we can gently imagine such a thing, that entire journey did not take billions of years. It did not take years at all. It did not take time. To understand this, we need to slow down, not the light, because it cannot slow, but our way of thinking. You and I live inside time. We feel it constantly, in the quiet ticking of a clock, in the slow rhythm of breath, in the way moments stack gently on top of one another, forming memory. Even when we are still, time moves forward for us. It carries us, whether we notice or not. But not everything experiences time in the same way. In physics, there is a quiet idea called proper time. You don't need to think of it as an equation or a formula. It is simply the time that something feels for itself, the time measured by a clock that travels along with it. For you, lying here, your proper time is flowing normally, second by second, thought by thought. But as something moves faster and faster, something strange begins to happen. From the outside, its clock appears to slow down. The faster it moves, the slower its time seems to pass. And when something reaches the speed of light, the speed at which all light moves, this slowing does not just become extreme, it becomes complete. For light, the passage of time disappears entirely. Not slows, not stretches, but vanishes. This means that for our photon there is no ticking clock, no waiting, no sense of duration between the moment it is created and the moment it is absorbed. From its own experience, though that word is not quite right, it does not travel through time the way we do. Instead, the moment it begins and the moment it ends are quietly joined together, like 2 points pressed into one. It is tempting to imagine what the photon sees. Perhaps the universe flattened into a thin line, perhaps everything compressed into a single instant. But here, the universe gently reminds us of its limits. A photon does not have a true point of view. It does not carry a camera or a memory. It does not observe the universe passing by. In fact, physics itself tells us that we cannot build a proper frame of reference moving alongside light. The idea breaks down. The equations lose meaning, and so, instead of saying the photon experiences no time, it is more careful and more accurate to say this: there is no time along its path. The beginning and the end are not separated by a duration. They're connected directly, like the ends of a thread pulled tight until no space remains between them. So while we imagine a long journey, billions of years across expanding space, the photon itself is not a traveller in the way we understand travel. It is something quieter. It is a connection, a link between two events, something emitted and something received. And everything we call the journey exists only from our side. This is the strange beauty of light. It reveals time to us, but does not belong to time itself. It carries stories across the universe, but does not live inside those stories. It is both everywhere along its path and nowhere in between. If you let this idea settle gently, it begins to feel less like a paradox and more like a soft shift in perspective. You're not just watching light travel, you're living inside the space where that travel appears to happen. The photon connects two distant moments, and you are part of one of them. And so tonight, as we follow this tiny piece of light, we are not simply tracing a path through space. We're exploring something deeper, a journey that, in one sense, lasted almost 14 billion years, and in another, never happened at all. Let that thought rest for a moment, like a ripple fading on still water, because from here, the story begins to open outward, back into the early universe, where light first struggled to move at all, and where our photon waited, not yet free, in a cosmos that had not yet learned how to let light travel. And in that waiting, something extraordinary was preparing to begin. Let's drift a little further back now, not by moving quickly, but by letting everything soften and expand around us. Before our photon could begin its quiet, timeless connection between two moments, there was a long period when such a connection simply wasn't possible. Not because light didn't exist, but because the universe itself had not yet learned how to let light move freely. It helps to imagine this not as darkness, but as something much stranger. A universe filled with light that could not see. In the earliest chapters of cosmic history, the universe was not empty. It was dense, hot, and alive with energy. Every direction was filled with motion, tiny particles colliding, scattering, exchanging energy in a constant, restless dance. Among them were photons, already present, already moving, already carrying energy. But they could not go anywhere. Every time a photon tried to move forward, it would almost immediately collide with something, most often a free electron. Not a gentle encounter, but a constant interruption. A step forward, then a deflection. Another step, another scattering, over and over again, in every direction. It was less like travelling through open space, and more like trying to walk through a crowded room where everyone is moving unpredictably. You might take a step only to be bumped sideways. Try again and you're pushed back. There is motion, yes, but no progress. This was the state of light in the early universe. Photons were everywhere. The universe was glowing intensely, filled with radiation. But that light could not carry a clear message from one place to another. It could not form an image. It could not travel in a straight line long enough to tell a story. In a quiet, almost poetic sense, the universe was bright, but blind. If you had somehow been there, floating in that early cosmos, you would not have seen darkness. You would have been surrounded by a brilliant, overwhelming glow. But you would not have been able to see anything clearly. No shapes, no distances, no stars or structures, just a uniform, glowing fog. Because light to be useful needs more than existence. It needs freedom. And at this point in the universe's life, that freedom had not yet arrived. The reason for this lies in the state of matter at the time. The universe was so hot that atoms, those stable combinations of protons and electrons, could not form. Instead, electrons moved freely, not bound to anything, constantly interacting with passing photons. And these free electrons were the key. They acted like countless tiny mirrors, scattering light in every direction, not reflecting it in neat angles like a polished surface, but diffusing it, interrupting it, breaking any sense of direction. Every photon was trapped in a constant cycle of interaction, so even though light existed, it was locked in place, not by walls, but by chaos. This period lasted for hundreds of thousands of years. Not long by cosmic standards, but long enough for something profound to build quietly beneath the surface. Because while all this scattering and motion continued, the universe itself was changing. It was expanding. And as it expanded, it was cooling. This cooling was not sudden. It was not dramatic. It was slow, steady, almost imperceptible, like the way a cup of tea cools when left untouched. The energy of the universe spread out, becoming less intense, less violent. The constant collisions began to soften. And with that softening, something new became possible. Electrons, which had once been too energetic to stay close to anything, began to slow down. Protons, tiny, positively charged centers, were already present, waiting. And gradually, gently, these two began to come together. They formed the first stable atoms, mostly hydrogen, the simplest and most abundant element in the universe. This moment is often given a technical name, but we can think of it more simply. It was the moment when the universe became calm enough to hold itself together. And with that change, something remarkable happened to light. When electrons became bound inside atoms, they stopped interfering with photons in the same chaotic way. They no longer acted like constantly shifting obstacles. The fog began to lift, not because light grew stronger, but because the obstacles grew quieter. The universe became transparent. For the first time, a photon could move forward and keep going. No longer trapped in endless scattering, it could travel in a straight path across space. It could carry information. It could connect distant regions of the cosmos. This was the moment our photon had been waiting for, though it did not wait in any conscious sense. It was simply part of the field, part of the energy of the universe, until suddenly the conditions changed. And when they did, it was released, not launched like a projectile, not aimed or directed, just free. It slipped into the newly transparent universe and began what we, from our perspective, call a journey. But even here, the strangeness remains. Because from the photon side, nothing like waiting ever happened. There was no sense of time passing during those hundreds of thousands of years. No delay, no anticipation. From its own path, it simply begins at the moment it is free, and ends at the moment it is absorbed. The vast stretch in between, that long era of the early universe, exists only for us as observers. We measure it, we describe it. We imagine the slow cooling, the formation of atoms, the clearing of the cosmic fog. But the photon does not move through that timeline the way we do. It connects 2 points across it. Still, from our side, this moment, the release of light, is one of the most important transitions in the history of the universe. Because this is when the universe begins to become knowable. Before this, even if something had been there to observe, there would have been no clear signal, no image, no structure, just scattered light with no direction. After this, everything changes. Light begins to carry information. It begins to record differences, tiny variations in temperature, density, motion. It becomes a messenger travelling across space, preserving traces of what it has passed. In a gentle way, we can say this. This is when the universe begins to remember itself, and our photon is one of the first memories. It leaves that moment of clarity and moves outward into a vast, expanding cosmos, one that is still quiet, still dark in many ways, but now open. Open enough for a story to unfold. And as it begins that long drift through space, through regions where nothing yet shines, where stars have not yet been born, it carries with it something subtle, something almost invisible. Not just energy, but the first whisper of a universe learning how to be seen. There is no single sound that marks the moment, no sudden brightness sweeping across space, no cosmic sunrise breaking through the darkness. Instead, what happens next unfolds so gently that, if you were there, you might not notice it at all. And yet everything changes. The universe, after hundreds of thousands of years of heat and constant motion, cools just enough for something delicate to take hold. Electrons, once restless and scattered, begin to settle. Protons, steady and patient, draw them close, and for the first time, they stay together. Atoms are formed, simple ones mostly. Hydrogen, the lightest and most common building block in the universe. Nothing complex, nothing intricate, but stable, quiet, complete in a way that the earlier chaos could not allow. This quiet bonding changes the behavior of everything around it. Because when electrons are free, they scatter light in every direction. They interrupt it, redirect it, prevent it from travelling any meaningful distance. But when electrons become part of atoms, they stop behaving like countless tiny obstacles. They become still. They become transparent. And so, almost without announcement, the fog lifts. Light, which had been trapped in a constant dance of collisions, is finally able to move freely. Not in bursts or flashes, but in smooth, uninterrupted paths. This is the moment when the universe becomes clear, and in that clarity our photon is released. Not born in the sense of being created from nothing. It was already there, already part of the restless sea of energy. But now, for the first time, it can begin a clean, uninterrupted path. It slips away from its surroundings and moves outward into space. No hesitation, no resistance, just motion. From our perspective, this is the beginning of a long and extraordinary journey, a journey that will span billions of years, crossing vast distances, witnessing the slow unfolding of cosmic structure. But from the photon's side, nothing like a journey begins. There is no feeling of departure, no sense of leaving one place for another. There is only the existence of two events, emission and absorption, quietly linked together, without any passage of time in between. Still, for us, standing here within time, this moment carries deep significance, because this light, this ancient glow, released when the universe first became transparent, is still with us. It has not disappeared. It has not faded away entirely. Instead, it has stretched. As the universe expanded, the space through which the photon moved also expanded, And as that space stretched, so did the photon's wave. Its rhythm slowed, its energy softened. What began as a hot, energetic form of light gradually shifted into something cooler, quieter, more subtle. Today, that ancient light still fills the universe. It comes from every direction, evenly, softly, like a whisper that never stopped echoing. We cannot see it with our eyes. It lies far beyond the range of visible light. But with sensitive instruments, we can detect it. It is often described as a faint background glow, left over from the early universe. But there is a gentler way to think about it. It is the afterglow of the moment the universe first became visible. Imagine standing in a room that has just been cleared of thick fog. For the first time, you can see across it. The air is still, but something remains, a faint trace of what once filled the space. Not a barrier anymore, but a memory. This ancient light is like that memory. It carries with it subtle variations, tiny differences in temperature and intensity that reflect the conditions of the universe at the moment it was released. These variations are incredibly small, almost imperceptible, but they hold immense meaning. They are the earliest patterns, the first hints of structure, the quiet beginnings of everything that would come later: galaxies, stars, planets, and eventually the conditions that would allow life to emerge. Our photon is one small part of this vast background, one thread in a tapestry that stretches across the entire sky. And like all the others, it carries information, not in words or symbols, but in the gentle details of its properties, its wavelength, its direction, its energy. All of these reflect the moment it was set free. This is what makes light so extraordinary. It does not simply illuminate what is, it preserves what was. When we detect this ancient light today, we are not just observing distant space, we are observing distant time. We are seeing the universe as it was when it first became transparent, long before any familiar structures had formed. The photon does not remember this. It carries no awareness, no memory in the way we understand it, and yet it is memory, because it has not changed in any fundamental way. It has not aged or decayed, it has simply moved, carrying with it the imprint of its origin. In that sense, light becomes a kind of bridge, not a path that stretches through time, but a connection between moments. The moment it was released, and the moment it is received. Everything we call its journey exists in between, but only for us. This realization shifts something subtle in how we think about the universe. We often imagine the past as something gone, something left behind, inaccessible except through inference or reconstruction. But light tells a different story. The past is still arriving. Every photon that reaches us from distant regions of space is carrying information from another time, not as a memory stored somewhere, but as a signal that has been travelling, or more accurately connecting, across the structure of space-time. And our photon, released in that early moment of clarity, has been part of that quiet flow ever since. It moves outward, through a universe that is still largely empty of structure. No stars yet, no galaxies, just vast regions of gas and expanding space. It does not interact, it does not pause, it does not notice, it simply continues. And as it does, something else begins to change, not in the photon itself, but in the universe around it. Gravity, patient and persistent, begins to gather matter together. Tiny variations, barely noticeable at first, start to grow. Regions of slightly higher density begin to pull in more material. Over time, these regions will become the seeds of galaxies and stars, but that is still far ahead. For now, the universe is quiet again, not chaotic as before, but calm in a different way. A vast, dark canvas, slowly preparing for its first points of light, and through it, Our photon drifts, carrying with it the earliest image the universe ever allowed itself to form, not knowing where it will arrive, not knowing that one day it might be captured, measured, and understood, not knowing that its quiet connection between two moments will become part of a much larger story, a story that slowly and gently is still unfolding. For a while, nothing shines, not in the way we think of shining at least. Our photon, newly free, moves through a universe that has become transparent but not yet luminous in the familiar sense. There are no stars scattered across the sky, no galaxies spinning quietly in the distance, no glowing clouds or bright points of reference, only vastness, only distance, and a kind of silence that is not empty but waiting. This period is sometimes described as the dark ages of the universe, not because there is no light at all, our photon and countless others like it are already travelling, but because there are no sources of new light yet. No stars have formed to ignite the darkness, no structures have condensed enough to begin shining on their own. It is a universe filled with motion, but without spectacle. Imagine standing in a place where the air is perfectly clear, stretching endlessly in all directions. There is nothing to block your view, nothing to obscure your sight, and yet there is also nothing to see. No landmarks, no colour, no movement you can recognise, not darkness as a barrier, but darkness as absence. That is the kind of quiet our photon moves through. From our perspective, this journey unfolds across millions of years. The universe continues to expand, slowly stretching the distances between everything. Matter drifts, ever so gently, responding to the faint pull of gravity. But from the photon side, nothing accumulates. There is no sense of passing through this long stretch of time, no awareness of duration. It is still, in that strange and quiet way, simply connecting its beginning and its end. And yet, for us this stretch matters, because this is where the stage is being prepared. Hidden within the apparent emptiness are tiny differences, subtle variations in density that were already present in the early universe. Some regions are just slightly denser than others, not enough to be seen, not enough to stand out, but enough to matter over time. Gravity begins its patient work here. It does not rush, it does not surge dramatically. It simply pulls slowly, steadily, drawing matter towards slightly denser regions. Over long periods, these small differences grow. Regions that were once almost identical begin to separate into distinct structures. The universe, which once appeared nearly uniform, begins to develop texture. But this process is incredibly slow. So slow that from moment to moment nothing seems to change at all. If you could observe it directly, you might feel as though time itself had paused, that everything was frozen in place. But beneath that stillness, something quiet and persistent is unfolding. Our photon passes through all of this without interruption. It does not slow down. It does not interact. It does not become entangled in these forming structures. It simply moves along the path available to it, unaffected by the slow gathering of matter around it. In a sense, it becomes a silent witness. Not a conscious observer, but a presence that passes through regions before they become anything recognizable. It crosses spaces that will one day host galaxies. It moves through areas that will eventually be filled with stars and planets. But for now, there is nothing to mark these places, no light to reveal them, no contrast to define them. Just a smooth, expanding background. This is what makes this era feel so different from what comes later. When stars begin to form, they will illuminate the universe in scattered points, breaking the darkness into patterns. Galaxies will take shape, adding structure and movement. Light will begin to interact with matter in visible ways, creating shadows, colours, and depth. But here, none of that exists yet. light is present, but it has no audience. There are no eyes, no instruments, no surfaces reflecting or absorbing it in ways that create recognizable images. The photon moves through space, carrying information from its origin, but there is nothing yet to receive that information in any meaningful way. It is like a message written long before anyone has learned how to read, and yet that message is preserved, unchanged, waiting. This waiting is not something the photon experiences, but it is something we can feel when we look back at this period. It gives the universe a sense of quiet anticipation, as though everything is holding its breath before the first lights begin to appear. Because eventually they will. In those slightly denser regions, matter will continue to gather. Clouds of hydrogen will grow thicker, pulled inward by gravity. As they collapse, they will heat up. Pressure will build. And deep within those clouds, the first stars will ignite. When that happens, the universe will begin to glow again, not as a uniform haze, but as a collection of distinct sources, points of brightness scattered across the darkness. But that moment is still ahead. For now, our photon continues its silent drift. It moves through space that feels endless, through time that stretches far beyond human comprehension, and yet for it, none of this unfolds step by step. There is no sequence, no before and after, only connection. This contrast between how we experience time and how light relates to it becomes more noticeable here in the quietest part of the journey. We imagine the photon travelling, passing through millions of years of cosmic evolution. We picture it crossing vast distances, moving steadily forward through an ever-changing universe. But from another perspective, it is not moving through time at all. It is simply linking two moments that for it are not separated. The beginning and the end are quietly joined, and everything we call the journey exists only in the space between them, a space we can see, measure, and describe, but one the photon itself does not inhabit in the way we do. As you let that idea settle, the darkness of this era begins to feel different, not empty, but full of quiet structure, not silent, but filled with processes too slow to hear, and within it, a single thread of light continues its path, carrying with it the earliest imprint of the universe, unchanged, unhurried, and untouched by time. Soon, the darkness will begin to break, but for now it remains, a vast, calm expanse, where light exists without being seen, and where the future is already beginning to take shape far beneath the surface. If you stay with the photon for a little longer, something subtle begins to reveal itself. At first, it seems like nothing is happening. The universe is quiet, dark, and wide open. Our photon moves freely, uninterrupted, crossing distances that feel almost impossible to imagine. But beneath that calm surface, something is quietly unfolding. Space itself is stretching. Not in a dramatic way, not like a sudden tearing or pulling apart, but slowly, steadily in every direction at once. Distances between things grow, not because objects are flying away through space, but because the space between them is expanding. This is one of the most delicate ideas in all of cosmology. Objects are not simply moving apart. The stage they sit on is gently widening. A helpful way to imagine this is to picture a soft, flexible fabric, like a sheet laid out, smoothly. Now imagine that sheet being stretched, not from one side, but from everywhere at once. Every point moves away from every other point, even though nothing is actively travelling across the surface. The distances increase because the surface itself is growing. This is what space is doing, and our photon is moving through it. Now, here is where something interesting happens. As space stretches, it affects the light travelling within it. Not by slowing it down. The speed of light remains constant, unchanged, but by gently stretching the light's own internal rhythm. Light can be thought of as having a kind of repeating pattern, like a wave. Not a physical wave in water, but a pattern of oscillation, like a steady up and down motion that defines its character. When space expands, that pattern is stretched along with it. The distance between each crest of the wave becomes slightly longer, and as that happens, the light changes. It becomes softer, cooler, less energetic. This process is often given a technical name, but we can think of it more simply as stretched light. Our photon, which began its journey in a hot, dense universe, gradually shifts as it moves through expanding space. Its wavelength, the spacing of its internal pattern, grows longer. Its frequency, the rate at which that pattern repeats, slows down. Not because the photon is losing energy in the way a moving object might slow down, but because the space it travels through is reshaping it. Imagine drawing a wave on a rubber band, then gently stretching the band. The wave becomes longer, more spread out, even though nothing about the original pattern has been erased. This is what the universe does to light. And so, over time, over billions of years from our perspective, the photon becomes quieter, not weaker in existence, but softer in expression. What began as a high-energy photon in the early universe eventually becomes something far more subtle. By the time such photons reach us today, many of them have shifted into forms of light that we cannot see directly with our eyes. They exist in a range far beyond visible light, long, gentle waves that require sensitive instruments to detect. And yet, despite this transformation, something essential remains unchanged. The photon still carries the imprint of its origin. It still connects the moment it was released to the moment it is received. The stretching of space does not break that connection. It only reshapes how the connection appears to us. This is where the idea of light as memory begins to deepen, because the amount by which a photon has been stretched tells us something very specific. It tells us how much the universe has expanded during its journey. In a quiet way, the photon becomes a kind of record, not written in words, but encoded in its properties. The longer its wavelength has become, the longer it has been travelling through expanding space. The softer its energy, the older its origin. It is as though each photon carries a timestamp, not a number, but a feeling embedded in its structure. When we detect such light, we are not just observing where it came from, we are learning when it began. This is how astronomers are able to look deep into the past, not by travelling backward, but by receiving light that has been stretched across time. The farther away something is, the more its light has been stretched. The deeper into the past we are seeing, distance and time become intertwined, not separate ideas but reflections of the same underlying process. And our photon, still moving silently through space, carries this information with it. It does not choose to do so. It does not encode or decode anything consciously. It simply exists as it is, shaped by the universe it moves through. This shaping is gentle, continuous, almost invisible from moment to moment. If you could pause the photon halfway through its journey, though in truth such a pause has no meaning for it, you would not see a dramatic change, just a slight stretching, a subtle shift. But over immense spans of time, these small changes accumulate into something profound. The universe leaves its fingerprint on the light, and light carries that fingerprint forward. This is what makes the photon more than just a moving particle. It becomes a messenger, not one that speaks, but one that reveals. It tells us how space has grown, how the universe has cooled, how the early conditions have unfolded into what we see now. And all of this happens without the photon ever experiencing any of it. There is no aging, no accumulation of time, no awareness of change. From its own path, it still exists only as a connection between 2 points. But from our side, it becomes something rich with history. This duality between timeless connection and evolving information is part of what makes light so deeply fascinating. It does not live inside time, and yet it carries time to us. It does not change in its own experience, and yet it reflects the changing universe. As you sit with this idea, the journey of the photon begins to feel less like motion and more like a quiet unfolding. Not a traveller moving through a fixed stage, but a thread being gently stretched as the stage itself expands. And somewhere ahead, far beyond the darkness, beyond the slow gathering of matter, new sources of light are beginning to prepare themselves. The first stars are not yet visible here, but their beginnings are already taking shape. And soon the universe will no longer be a place where light only drifts. It will become a place where light is born again. As the photon continues its quiet path through the expanding universe, something becomes clearer, not in the sense of brightness, but in meaning. It is no longer just a piece of light moving through space. It is becoming a record. Not a record in the way we keep memories, with thoughts and images stored somewhere inside. The photon does not remember anything. It does not look back. It does not carry a story in the way a mind would, and yet it carries a story. This may seem like a contradiction at first, but it becomes gentler when you think of it this way. Imagine placing your hand in soft clay. You press lightly, then lift your hand away. The clay does not remember your hand in any conscious sense. It does not think or reflect, but it has been changed. It now holds the shape of that moment. Light works in a similar way. As the photon moves through the universe, it is shaped by the conditions it encounters, not by collisions or interruptions in this quiet era, but by the expansion of space itself. The stretching of its internal rhythm, the gradual softening of its energy, these are not random changes, they are imprints, and those imprints can be read. When we receive light that has travelled for billions of years, we are not just detecting its presence, we are reading the subtle ways it has been shaped along the way. The length of its wave, the direction it arrives from, the tiny variations it carries, all of these contain information, not stored deliberately, but preserved naturally. In this sense, the photon becomes something like a messenger, though it never chose to deliver a message. It carries with it the conditions of the universe at the moment it was released, and the gentle transformations that occurred as it moved through space. And when that light reaches us, when it touches a detector or a telescope or even the sensitive cells in an eye, it becomes something else again. It becomes knowledge. This transformation is quiet but profound. The photon arrives, transfers its energy, and disappears. But in that moment, something new is created. A signal, a measurement, a piece of data. And from that data, an image, a map, a deeper understanding of the universe. It is as though the photon completes its purpose only when it is received, not because it intended to, but because the connection it represents is finally closed. The beginning and the end meet, and in that meeting meaning emerges. This is why light is often described as a bridge between times. When we look at distant galaxies, we're not seeing them as they are now. We're seeing them as they were when their light began its journey. The farther away they are, the longer their light has travelled, and the further back in time we're looking. Distance becomes a kind of time machine, not one that moves us, but one that brings the past to us. And our photon, released in the early universe, carries one of the oldest images possible. It reflects a time when the universe had just become transparent, when structure was only beginning to form. It carries a snapshot of that moment. But unlike a photograph, which captures an image and stores it in place, this snapshot moves. It travels, or more precisely, it connects across the vast structure of space-time waiting to be received. And when it is, the past becomes present. This is where the idea of light as memory becomes most meaningful. The universe does not have a central archive. There is no place where all moments are stored and labelled. Instead, the memory of the universe is distributed, spread out across space, carried by light itself. Every photon that reaches us is a fragment of that memory. Some are recent, coming from nearby stars. Others are ancient, carrying information from the earliest moments after the universe became clear. Each one adds a piece to the larger picture, and when we gather enough of these pieces, patterns begin to emerge. We see the large-scale structure of the cosmos, we trace the formation of galaxies, we measure how the universe has expanded over time. All of this comes from reading the subtle imprints carried by light. It is a slow process, patient, built from countless tiny signals, but it allows us to reconstruct a history that we could never observe directly. And all of this depends on something very simple, the fact that light can travel freely. If the early universe had remained opaque, if photons had continued to scatter endlessly, none of this would be possible. There would be no clear signals, no images, no way to look back. The universe would remain hidden, even from itself. But because it became transparent, because photons were released and allowed to move freely, the universe gained a kind of visibility, not just in the present, but across time. Our photon is part of that visibility. It moves through space, unchanged in its essential nature, but shaped gently by the expansion of the universe. It carries with it the imprint of its origin and the quiet influence of everything it has passed through. And as it continues, something else begins to change. The universe is no longer entirely dark. In certain regions, matter has gathered enough for new processes to begin. Clouds of hydrogen pulled together by gravity have grown dense and warm. Within them, something new is about to happen. Something that will transform the quiet darkness into a landscape of light. The first stars are beginning to form. They are not yet visible from our photon's path, but their presence is emerging. Deep within collapsing clouds, temperatures rise, pressures increase, and the conditions for nuclear fusion begin to take shape. When these first stars ignite, they will flood the universe with new light. Light that is born not from the early conditions of the cosmos, but from the ongoing processes within these newly formed structures. The universe will begin to shine again, not as a uniform glow, but as a scattered pattern of brilliance. And when that happens, the journey of light will become more complex. Photons will not only drift through empty space, they will be born, absorbed, scattered, and transformed in new ways. The simple, uninterrupted path our photon has followed will give way to a richer, more dynamic environment. But for now, it continues its quiet connection, carrying memory without remembering, linking moments without experiencing time, and moving, always moving, from a beginning that still echoes toward an ending that has not yet arrived. As the photon continues its quiet connection across the universe, something begins to change, not in the photon itself, but in the world unfolding around it. The darkness is no longer completely uniform. At first, the differences are so subtle, they almost don't seem real. A slightly denser region here, a slightly emptier region there. Nothing you could point to, nothing you could clearly see. But over time, slow, patient time, measured only from our side, these tiny differences begin to grow. Gravity, which has been working silently in the background, begins to gather matter more noticeably now. Not in sudden bursts, not with dramatic force, but with a steady pull that never stops. regions that were once only slightly denser begin to draw in more material, and as they do, they become even denser still. A gentle imbalance begins to amplify itself, like a whisper slowly becoming a voice. Gradually, the universe develops structure, not as isolated objects scattered randomly, but as something far more intricate. A vast interconnected pattern begins to emerge, what scientists often describe as a kind of cosmic web. But you don't need that phrase to feel what it is. Imagine drifting through an enormous, invisible network, not made of solid threads, but of regions where matter has gathered more thickly, forming long, delicate filaments that stretch across unimaginable distances. These filaments connect larger nodes, dense regions where matter has pooled together more strongly. These will one day become clusters of galaxies, crowded neighborhoods of stars and light, and between them there are vast empty spaces, voids, regions where very little matter remains, stretched thin by the expansion of the universe. These voids are not completely empty, but compared to the filaments and clusters, they feel like enormous cosmic deserts. Our photon moves through all of this, and for the first time, the idea that it is travelling through empty space begins to feel incomplete. Because space is not truly empty, it has shape, it has structure, it has a kind of hidden architecture that becomes more apparent the longer we look. The photon drifts along, crossing these vast regions without resistance. It does not slow as it passes through denser areas. It does not hesitate when moving through emptier ones. It simply follows its path, quiet, uninterrupted, unchanged in its own timeless way. But from our perspective, the environment it moves through is becoming more and more complex. If you could see the universe from far above, far enough to take in its larger scales, you would not see a random scattering of galaxies. You would see something more like a delicate lacework or the branching patterns of roots spreading through soil, long strands, intersections, open spaces, all connected, all evolving. This is the stage through which our photon continues its journey, and yet even here, it remains untouched in a very particular sense. It does not become part of the structures it passes. It does not get caught in them. It does not orbit or settle. It simply moves through, like a thread being drawn across a vast tapestry without ever becoming woven into it. This is one of the quiet contrasts at the heart of the story. Matter gathers, matter slows. Matter forms structures, stars, galaxies, clusters. But light does not. Light remains free. It does not accumulate. It does not build. It does not settle into place. It continues, always at the same unchanging speed, moving along the geometry of space itself. And yet, even though the photon does not become part of these structures, it is still shaped by the universe in more subtle ways. The path it follows is not perfectly straight in the way we might imagine, because space itself is not perfectly flat. Where matter gathers more densely, space becomes gently curved, not sharply bent like a folded sheet, but softly shaped, like a landscape with hills and valleys. And while the photon does not feel force in the way matter does, it does follow this shape. It moves along the curves of space. So as it passes near these growing structures, these filaments and clusters, it begins to trace paths that are ever so slightly altered by their presence. Not dramatically, not enough to be noticed in a single moment, but over long distances these gentle curves begin to matter. The photon's path becomes part of the larger geometry of the universe. It is guided, not by intention, but by the structure of space itself. If you imagine a river flowing across a landscape, it does not choose its path consciously. It follows the shape of the land. It bends where the ground dips. It curves around obstacles. It flows naturally along the contours that already exist. light behaves in a similar way. It follows the shape of space, and space shaped by matter gives that path its form. So as our photon drifts through the cosmic web, it is not just moving through a static background. It is moving through a living structure, one that is slowly growing, slowly evolving, slowly becoming more defined. And still, through all of this, the photon remains what it has always been, a connection. It does not experience the slow growth of these structures. It does not witness the formation of galaxies or the gathering of matter. It does not pause to observe the web taking shape around it. All of that exists only from our side, from within time, from within a perspective that unfolds moment by moment. But the photon itself continues to link two distant events: its release in the early universe and its eventual arrival somewhere far ahead. And everything in between, the filaments, the voids, the slow shaping of the cosmos, is part of the stage through which that connection is drawn. As you let this image settle, the universe begins to feel less like empty space, and more like something quietly intricate, not chaotic, not random, but structured in a way that only becomes visible when you step far enough back. And within that structure, a single thread of light continues its silent path, crossing regions that will one day be filled with galaxies, passing through spaces that will remain nearly empty, and gently tracing the shape of a universe that is still in the process of becoming. Soon, that structure will grow brighter, because within these filaments and clusters, something new is beginning to awaken. Matter is gathering more tightly now, and in the densest regions, the conditions are almost ready for something remarkable. The first true sources of light since the early universe are about to ignite. As the photon continues its quiet passage through the vast structure of the universe, something begins to happen. Not in sudden or dramatic ways, but in touches so gentle, they might almost be missed. Up until now, its journey has felt smooth and uninterrupted. It moved through darkness, through expanding space, through the growing architecture of the cosmic web, without ever being stopped or captured. But the universe is no longer entirely empty. There are regions now where matter has begun to gather more noticeably. Thin clouds of gas stretching between structures, faint traces of particles spread across space, and subtle concentrations of invisible mass shaping everything from behind the scenes. And as the photon passes through these regions, it is not entirely untouched. It is changed, not in a way that disrupts its path, not in a way that alters its destination, but in ways so delicate that only careful observation can reveal them. To understand this, it helps to imagine something very simple. Picture a beam of light passing through a thin mist. You might not notice the mist at first. It does not block the light completely. It doesn't cast a strong shadow. But if you look closely, you might see the light dim slightly, or shift in colour, or scatter just a little. The mist leaves a trace, not a memory, not a record in the way we think of it, but a subtle change in the light itself. This is similar to what happens as our photon passes through the universe. Along its path, it may move through regions filled with hydrogen gas, atoms drifting quietly in space. These atoms can interact with light in very specific ways. They can absorb certain patterns within the light, removing tiny pieces of its structure. Not enough to stop it, not enough to erase it, but enough to leave a mark. If you were to examine that light carefully after it has passed through such a region, you would notice that something is missing. Certain notes in its pattern have been softened or removed. It is as though the light once carried a full melody, and now a few of its tones have been gently muted. These missing pieces tell a story. They reveal what the light has passed through. They allow us to detect clouds of gas that are otherwise invisible, regions that do not shine, do not reflect, and cannot be seen directly, but still leave their imprint on the light that travels through them, and this is only one way the universe leaves its fingerprints. There are also influences that are even more subtle, not from visible matter, but from something we cannot see at all: dark matter. This form of matter does not emit light. It does not reflect it. It does not interact with it in the usual ways, and yet it shapes the universe profoundly through its gravity. As our photon moves through the cosmic web, it passes through regions where dark matter is present, forming invisible scaffolding that guides the formation of galaxies and clusters. The photon does not collide with this invisible structure, but it does feel its presence in another way, through the shape of space. Dark matter, like all forms of mass, curves the space around it, and as we have already seen, light follows these curves, so even though the photon never directly interacts with dark matter, its path is gently influenced by it. A slight bending here, a subtle shift there. Changes so small they're almost imperceptible, but when observed across many photons, across vast distances, they begin to reveal patterns. It is like watching leaves drift along a stream. Each one moves quietly, carried by the water. But by observing their paths, you begin to understand the flow beneath the surface, the currents, the shape of the riverbed, the unseen forces guiding everything along. Light becomes our way of sensing what we cannot see directly, not by illuminating it, but by responding to it. And so, the photon becomes something more than a simple traveller. It becomes a witness, again, not consciously but physically. It carries the marks of everything it has passed through, not as memories, but as changes. As you sit with this idea, something gentle begins to shift. The photon is no longer just connecting two moments. It is gathering the quiet influence of the universe along the way. Each region it crosses leaves a trace. Each interaction, no matter how small, becomes part of its story, and by the time it reaches its destination, it is no longer exactly as it was when it began. It has been shaped, refined, subtly rewritten by the cosmos itself. And this is what allows us to read the universe. When we capture light from distant regions of space, we are not just detecting its presence. We are examining its details, looking for the tiny alterations that reveal what it has encountered. From these details, we can map the distribution of gas across the universe. We can trace the large-scale structure of matter. We can even infer the presence of dark matter, not by seeing it directly, but by observing how it has influenced the path of light. All of this comes from the fact that light, while it does not remember, is never completely untouched. It carries the imprint of its journey, and yet from its own side none of this unfolds. There is still no passage of time, no sequence of events, no accumulation of experience. All of these changes exist only in the way we observe the photon, from within time, from within a perspective that stretches across billions of years. For the photon, the beginning and the end remain directly connected. But for us, the space in between becomes rich with meaning. It becomes a story we can read. And as our photon continues, something else begins to emerge. The regions it passes through are no longer just faint clouds and invisible structures. In the densest parts of the cosmic web, matter has gathered enough to ignite something new. The first stars are beginning to shine, and with them, the universe is about to enter a new phase, one where light is no longer just drifting quietly from the past, but being created anew in brilliant, energetic bursts. The darkness that once stretched across everything will begin to break, and our photon, still carrying the earliest imprint of the universe, will soon pass through regions filled with new light, light born from the fires of stars. By now, the universe around our photon is no longer quiet in the same way it once was. The darkness has begun to loosen its hold. Structures are grown more defined. Matter has gathered into long filaments and dense clusters. The first stars are beginning to glow faintly in the distance, like embers just beginning to catch. And with all of this, something else becomes more noticeable: the shape of space itself. Up to this point, it has been easy to imagine the photon moving through a kind of empty stage, a vast open background where things simply exist and drift apart. But the deeper we look, the more we begin to realize that this stage is not flat, not rigid, and not unchanging. It bends, gently, quietly, but undeniably. Where matter gathers, space curves. Not like a sharp fold in paper, but like a soft depression in a stretched surface. The presence of mass, whether it is a cloud of gas, a forming galaxy, or a dense cluster, subtly reshapes the space around it. And light, which always moves along the structure of space, follows these curves. It does not resist them. It does not push against them. It simply moves along the path that space provides. A helpful way to feel this is to imagine a wide, slow-moving river flowing across a landscape. The water does not choose where to go. It follows the contours of the land, the dips, the slopes, the gentle curves carved over time. Where the ground bends, the river bends. Where the terrain shifts, the path adjusts. Light behaves in much the same way. It follows the shape of space. And as our photon passes near regions where matter has gathered, its path begins to curve ever so slightly, not enough to notice in a single moment, not enough to feel like a sudden change. But across immense distances, these tiny curves accumulate. The path is no longer a perfect straight line. It becomes a graceful arc, shaped by the presence of mass. This bending of light is one of the most subtle and most revealing features of the universe, because it allows us to see things that would otherwise remain hidden. Imagine looking at a distant object through a piece of glass that is slightly uneven. The object appears distorted, not because the object itself has changed, but because the path of the light reaching your eyes has been altered. Now imagine that instead of glass, the distortion is caused by an entire galaxy, or a cluster of galaxies. The light from something far behind passes near this massive structure, and its path bends as it travels toward us. The result is an image that appears stretched, curved, or even duplicated. Sometimes, a single distant object appears as multiple arcs of light, arranged around an invisible center. Not because there are many objects, but because the path of light has been shaped along the way. This effect allows us to detect structures that do not shine on their own. We can map the distribution of matter, not just visible matter, but also the unseen forms that influence space through gravity. By observing how light bends, we can infer the presence of mass that would otherwise remain completely hidden. In this way, light becomes more than a messenger. It becomes a guide. It reveals the shape of space itself. Our photon, moving quietly through this evolving universe, becomes part of this process. As it passes near regions of greater mass, its path curves slightly, adjusting to the geometry of space. It does not decide to bend. It simply follows. And in doing so, it carries with it information, not just about where it began, but about what it passed near. This deepens the idea we explored earlier: light does not remember, but it is shaped. And those shapes can be read. If many photons pass through the same region, and we observe their paths carefully, patterns begin to emerge. We see consistent distortions, subtle alignments, gentle arcs that reveal the underlying structure of space. It is like watching the surface of water ripple around a submerged object. You cannot see the object directly, but you can see its influence. The way the water moves tells you something about what lies beneath. In the same way, Light reveals the hidden architecture of the universe. And yet, even as all of this unfolds, from our perspective, across vast stretches of time, the photon itself remains untouched by time. It does not experience the slow bending of its path. It does not feel the gradual shaping of space. It does not notice the emergence of stars or the gathering of galaxies. All of this exists only in the unfolding story we construct. For the photon, the beginning and the end are still directly connected. The path, with all its gentle curves, exists only as part of that connection, not as a sequence of moments, but as a single, continuous link. This is where the story begins to deepen again, because we now see that the photon is not just moving through space, it is tracing the structure of the universe. Every curve in its path reflects something real. Every subtle shift reveals the presence of mass, the shape of space, the quiet influence of gravity. And yet, from its own side, none of this is experienced. The entire path exists at once, as a connection, as a link between two events that, for the photon, are not separated by time. As you let that idea settle, the universe begins to feel different again, not just as a place where things exist and evolve, but as a dynamic, interconnected structure, one where space itself bends and shapes the paths of light, and where light in turn reveals that shape to us. And somewhere ahead, beyond these curved paths and growing structures, something new is about to take center stage. The first stars are no longer just forming, they're beginning to shine, bright enough to transform the darkness, bright enough to create new light, light born not from the early universe, but from the ongoing processes within these dense regions. And as our photon continues its quiet connection, it will soon pass through a universe that is no longer dim and diffuse, but alive with points of brilliance. A universe where light is not only drifting, but being born again. While our photon continues its quiet connection across the universe, moving through curved space, carrying the faint imprints of everything it has passed, something else is unfolding, much closer to home. On a small planet orbiting an ordinary star, beings have begun to notice light. At first, not as a scientific concept, not as something to measure or define, but as a simple, undeniable experience. The warmth of sunlight on skin, the glow of fire in the night, the difference between seeing and not seeing. And from these simple experiences, a question begins to form. What is light? It's a question that seems almost too obvious to ask. Light is everywhere. It fills our days, shapes our surroundings, defines our sense of space. And yet, when we try to understand what it truly is, it begins to slip just beyond easy explanation. Long before telescopes, before equations, before the language of science as we know it, people began to wonder. In ancient times, some believed that light came from the eyes themselves. That vision was a kind of reaching outward, a beam extending from the observer to the world. It is an idea that feels unusual now, but it reflects something deeply intuitive. The sense that seeing is an active process, something we do rather than something that happens to us. Others suggested the opposite, that light comes from objects and enters the eyes, carrying information inward, that what we see is not something we project, but something we receive. These early ideas were not experiments in the modern sense, but they were careful attempts to make sense of experience. Observations were made, patterns were noticed, and slowly, over time, a more consistent picture began to emerge. Light travels, it reflects, it bends. These were discoveries made not through complex instruments, but through patient observation, through noticing how light behaves when it encounters surfaces, how it changes direction when moving from one material to another, how it can be focused redirected, and shaped. There were thinkers who explored these patterns deeply, studying how light reflects off mirrors and how it bends when passing through water or glass. They began to describe these behaviours in systematic ways, laying the foundation for what would later become the science of optics. But even as these patterns became clearer, the deeper question remained: what is light itself? Is it something that flows continuously, like a smooth wave spreading through space? Or is it made of tiny pieces moving like particles? This question would remain unresolved for centuries, and it is here that the story begins to take on a familiar shape, a kind of back and forth between two ways of understanding the world. On one side, there was the idea of light as a stream of tiny particles, small discrete bits moving in straight lines. This view made sense of reflection, of shadows, of the way light seems to travel directly from a source to a surface. On the other side, there was the idea of light as a wave, something that spreads, bends, and overlaps with itself, creating patterns of brightness and darkness. Each perspective explained some aspects of light beautifully, and each one struggled to explain others. This tension did not resolve quickly. It stretched across generations, with different thinkers favouring one view or the other, refining their ideas, testing them, and sometimes disagreeing quite strongly. But beneath all of this, something deeper was happening. Human understanding was evolving, not in a straight line, but in a gradual unfolding, much like the universe itself. Ideas formed, expanded, were challenged, and reshaped. New observations led to new questions, and with each step the mystery of light became both clearer and more complex. What makes this part of the story especially meaningful is that it mirrors the journey of the photon itself. While light travels silently across the cosmos, connecting distant moments without experiencing time, we, living within time, are slowly building an understanding of what that light is. We are in a sense meeting it from the other side. The photon does not know where it will arrive, but we are learning how to receive it. And as this understanding grows, it begins to reshape not just how we think about light, but how we think about reality itself. Because light is not just something we see, it is how we see. It defines distance, reveals structure, and carries information from places we cannot reach. It is the thread that connects observation to understanding, turning distant events into present knowledge. And yet, despite its familiarity, it continues to resist simple definition. Is it a thing, a process, a pattern, or something else entirely? These questions linger as we move forward in the story, because soon the debate between waves and particles will sharpen. Experiments will reveal behaviours that challenge both perspectives, and light will begin to show a dual nature, one that does not fit neatly into either category. But for now, we remain in this earlier moment, a moment of curiosity, of observation, of careful wondering. The photon continues its silent path shaped by the universe, carrying its subtle imprints, and here, on this small world, minds are beginning to reach toward it, not to grasp it, but to understand it, to ask gently and persistently, what is light, really? As human curiosity deepened, the question of light did not fade. It sharpened. The more carefully people observed how light behaved, the more it seemed to resist simple answers. It reflected cleanly from mirrors. It cast sharp shadows. It appeared to travel in straight lines, like something solid, something directional. And yet, it also bent. It spread out. It passed through narrow openings and created patterns that seemed too soft, too fluid to belong to something made of tiny, rigid pieces. It was as though light was quietly revealing two different personalities depending on how you looked at it. And so, over time, two main ways of understanding light began to take shape. One imagined light as a stream of tiny particles, small, discrete units moving rapidly through space. These particles, sometimes called corpuscles, were thought to travel in straight paths, bouncing off surfaces in predictable ways. This idea made sense of reflection, of shadows, of the crisp outlines we see when light is blocked or redirected. If light were made of such particles, it would behave much like a shower of fine grains, each one moving independently, following clear paths. This view was simple, intuitive, and for a long time it seemed sufficient. But there was another way of seeing light, a quieter, more fluid idea. In this view, light was not made of particles, but of waves, patterns that spread through space, much like ripples moving across the surface of water. These waves could bend around obstacles, overlap with one another, and create patterns of reinforcement and cancellation. If you have ever watched waves in a pond, you may have noticed how they interact. Two ripples can meet and briefly form a larger crest, or cancel each other out, leaving a moment of stillness. This kind of behaviour felt very similar to what light sometimes seemed to do. This wave idea explained something that the particle view struggled with. When light passes through a narrow opening, it does not always continue in a straight line. Instead, it spreads out slightly, creating a soft pattern beyond the opening. This spreading feels natural for a wave, but harder to explain if light is made only of tiny particles moving straight ahead. And so, the debate continued. Two models, two ways of seeing, each one capturing part of the truth, each one incomplete. What makes this moment in the story so gentle and so human is that both perspectives were built from careful observation. Neither was careless. Neither was imagined without reason. Each one was an honest attempt to understand something that didn't easily reveal its nature. And for a long time, it seemed as though one of these views would eventually win, that the question would be settled, that light would be revealed as either a particle or a wave. But the universe, as it often does, had something more subtle in mind. As experiments became more refined, something unexpected began to appear. Light could behave like a wave in one situation, and like a particle in another, not switching back and forth in time, but revealing different aspects depending on how it was observed. In some experiments, light spread and interfered like ripples, creating patterns that could only be explained if it were a wave. In others, it arrived in small, localized bursts, as though it were made of individual pieces, tiny packets delivering energy in discrete amounts. It was not just one, and it was not just the other. It was both, but not in a simple combination, not like a mixture of particles and waves blended together. Instead, it was something deeper, a kind of dual nature that did not fit neatly into either category. To understand this, it helps to soften our expectations. We often want things to belong to clear categories, solid or fluid, continuous or discrete, particle or wave. These categories help us organize the world, make sense of it, feel grounded in our understanding. But light does not settle comfortably into these categories. It stretches them. It invites us to see beyond them. Imagine trying to describe a melody using only the idea of individual notes, or only the idea of a continuous flow. Neither description alone captures the full experience. The melody is made of notes, yes, but also of the way they connect, overlap, and unfold. Light is similar. It has aspects that feel like particles, localized, countable, arriving in distinct interactions, and it has aspects that feel like waves, spread out, continuous, capable of overlapping and creating patterns. These are not two separate behaviors stitched together. They are two ways of interacting with something that lies deeper, and this realization begins to shift how we think. The question is no longer which is correct, But what kind of thing must light be to appear this way? As we follow our photon through the universe, this question becomes more than historical curiosity, because the photon itself embodies this dual nature. It travels in a way that reflects wave-like behaviour, spreading, bending, following the shape of space. And yet when it arrives, when it's finally absorbed, it does so in a single, discrete event. A specific transfer of energy, a localized interaction. It's both extended and precise, both spread out and focused. And this duality is not a flaw in our understanding. It is a clue, a sign that the deeper nature of light, and perhaps of reality itself, does not conform to the simple categories we are used to. As this idea settles, the debate between waves and particles begins to feel less like a conflict and more like a doorway, a transition, an invitation to look deeper. Because soon, new discoveries will push this understanding even further. Experiments will reveal that light delivers energy in small, indivisible amounts. The idea of the photon will take on clearer meaning, and the foundations of a new kind of physics will begin to emerge, one that embraces this dual nature rather, than trying to resolve it into a single form. But for now we remain in this moment of quiet tension, where light refuses to choose, where two ways of seeing overlap gently, without cancelling each other, and where our photon continues its silent connection, carrying with it both the spread of a wave and the precision of a particle as it moves toward a destination that still lies far ahead. There comes a moment in the story of light when curiosity becomes something more focused, less like wondering and more like listening carefully. By now, people had learned a great deal about how light behaves. It reflects from mirrors, bends through glass, spreads through openings, and casts shadows that feel precise and predictable. The ideas of waves and particles had both taken root, each explaining part of what was observed. But there was still a quiet tension, a sense that something deeper remained hidden beneath these two ways of seeing. And so, an experiment was designed, simple in its setup but profound in what it revealed. Imagine a thin barrier with two narrow openings cut into it, just two slits side by side. Behind the barrier, a screen waits to catch whatever passes through. Now imagine shining a beam of light toward those two openings. If light were purely made of particles, tiny bits moving in straight lines, you might expect something straightforward. Each particle would pass through one slit or the other, and on the screen behind you would see two bright bands aligned with the slits themselves. Two paths, two results, simple. But that is not what appears. Instead, the light spreads out after passing through the slits. The two streams overlap, and where they overlap, something delicate begins to form, a pattern of alternating bright and dark bands. Not random, not chaotic, but structured. The bright regions appear where the light waves reinforce each other, rising together. The dark regions appear where they cancel, one, rising while the other falls, leaving a moment of stillness. This kind of pattern is deeply familiar in waves. You can see it in water, where ripples meet and interact. You can hear it in sound, where overlapping tones create regions of resonance and silence. And here, light behaves in the same way, as though it were a wave. But the story does not end there, because the experiment can be made even more gentle. Instead of shining a continuous beam of light, imagine sending individual photons one at a time toward the slits. Not a steady flow, just one, then another, then another. You might expect that, with only one photon at a time, the wave pattern would disappear. After all, how can a single particle interfere with anything? There is nothing else present to overlap with. And yet over time, as many individual photons are sent through the slits, the same pattern begins to emerge. each photon arrives at the screen as a single localized point, like a tiny dot appearing in a specific place. But as more and more photons arrive, those dots begin to form the familiar pattern of bright and dark bands. It is as though each photon is contributing to a larger structure, even though it arrives alone. This is where the mystery deepens, because it suggests that each photon does not simply pass through one slit or the other. In some sense, it behaves as though it explores both paths, not in a physical, everyday way, not like splitting into two separate pieces, but in a way that reflects its wave-like nature. It spreads, it overlaps with itself, and the result of that spreading determines where it eventually appears. This is not something we can picture easily. It does not fit into the idea of a particle moving along a single path, nor into the idea of a wave that is always spread out. It is something in between, or perhaps something beyond. And the story becomes even more subtle when we try to observe which slit the photon passes through. If we place a detector near the slits, something that can gently tell us which path the photon takes, the pattern changes. The interference disappears. The delicate bands fade away, replaced by something simpler, two clusters aligned with the slits, as though, by asking the question, which path did it take, we have changed the behavior of the light, not by force, not by pushing or pulling, but by interacting with it in a way that alters the conditions of the experiment. This is one of the quiet turning points in our understanding of light, because it shows that light does not behave as a fixed thing with a single identity. Instead, it responds to how it is observed. When allowed to move freely without being measured in a specific way, it behaves like a wave, spreading, overlapping, creating patterns. When we try to pin it down to determine its exact path, it behaves more like a particle, localized, specific, definite. It is not switching back and forth in time, it is revealing different aspects of itself depending on the situation. And this invites a deeper question, not just what is light, but what does it mean to observe something? Because the act of observation is no longer passive, it becomes part of the phenomenon itself. As our photon continues its silent connection across the universe, this idea adds a new layer to the story. The photon is not simply travelling along a fixed path. It exists as a set of possibilities, ways it could move, paths it could take, until it is finally received. And when it is received, one outcome becomes real. One path becomes defined. The connection is completed. This does not mean that the photon is choosing or thinking or deciding. It simply reflects the deeper structure of reality, one in which outcomes are not fully determined until interactions occur, and this structure is not limited to light. It extends to the very fabric of the universe. But for now, we stay with the photon, a single piece of light moving through space without experiencing time, carrying with it both the spread of a wave and the precision of a particle, a presence that cannot be fully described in either language alone. And as we follow it further, this dual nature will begin to take on even greater meaning, because soon we will see that light does not just behave in discrete ways, it delivers energy in discrete amounts, small, indivisible packets. And from that realization, a new understanding will begin to form, one that reshapes not only our view of light, but of reality itself. As the understanding of light continued to grow, something unexpected began to appear. Not in the vastness of space this time, but in careful experiments, quiet, controlled, and patient. Up until this point, the idea of light as a wave had become increasingly convincing. It spread, it interfered, it formed patterns that felt smooth and continuous. It behaved like something that flowed, like a gentle ripple moving outward through space. And yet, When scientists began to look more closely at how light interacts with matter, a different kind of behavior began to emerge. Something more precise, more discrete. Imagine a smooth stream of water flowing over a surface. It feels continuous, unbroken, like something that can be divided endlessly into smaller and smaller parts. Now imagine rain. Not a continuous flow, but individual drops, each one separate, each one carrying a small, specific amount of energy when it lands. This is the shift that begins to take shape. Light, which had seemed like a continuous wave, begins to behave as though it arrives in tiny individual packets, small bursts, discrete moments. This idea becomes especially clear when light interacts with certain materials, such as metal surfaces. If you shine light onto a metal, something subtle can happen. Electrons, tiny components within the atoms of the metal, can be released, gently pushed out of their positions. At first glance, this might not seem surprising. If light carries energy, then shining enough of it onto a surface should eventually provide enough energy to release these electrons. But here is where the behavior becomes unexpected. You might imagine that if the light is very bright, if a lot of energy is being delivered, then electrons would be released more easily, that a stronger light would always have a stronger effect. But that is not quite what happens. Instead, what matters is not just how much light is present, but the character of the light itself, how energetic each individual packet is. If the light is too gentle, too low in energy, no electrons are released at all. No matter how long you wait, no matter how much of that gentle light you shine, it is like trying to push open a door with a very soft touch. You can press gently for as long as you like, but if the push is not strong enough, the door will not move. But if the light comes in sharper, more energetic packets, even if there are fewer of them, electrons are released immediately, not gradually, not after a delay, but instantly, as though each packet of light delivers a complete unit of energy in a single interaction. This is the key insight. Light does not deliver energy in a smooth, continuous flow. It delivers energy in small, indivisible portions. Each photon, each tiny piece of light, carries a specific amount of energy, and when it interacts with matter, it transfers that energy all at once, like a raindrop landing on a surface. Not spread out over time, but delivered in a single, complete moment. This realization changes how we think about light. It is no longer enough to describe it as a wave spreading smoothly through space. It must also be understood as something that arrives in distinct countable units, not separate from its wave-like nature, but intertwined with it. The wave describes how light spreads. The packet describes how it interacts, and both are necessary to understand what is happening. As we return to our photon, this idea takes on a more personal meaning, because this photon, the one we have been following since the early universe, is not just a ripple moving through space. It is also one of these packets, a single, complete unit of energy. When it finally reaches its destination, whether it is a telescope, a sensor, or a human eye, it will not arrive gradually. It will not smear itself across time. It will arrive in an instant. Its energy will be transferred in one discrete event, and then it will be gone. This moment of arrival is not stretched out. It is not divided. It is complete. And in that completeness, the connection it represents is fulfilled. The beginning and the end meet. This idea of light as both a spread-out wave and a localized packet may feel unusual at first, but it begins to settle when we stop trying to force it into familiar categories. Light is not simply one thing or another. It is something that reveals different aspects of itself depending on how it interacts with the world. When it moves through space, it behaves like a wave, spreading, bending, following the shape of the universe. When it interacts with matter, it behaves like a particle, delivering energy in precise, indivisible amounts. These are not contradictions. They are complementary views of something deeper, and this deeper nature begins to guide us toward a new understanding, not just of light, but of reality itself. Because if light, something so fundamental to our experience, behaves in this dual way, then perhaps the underlying structure of the universe is not as simple as we once believed. Perhaps the distinction between things and processes is not as clear as it seems. Perhaps what we call a particle is not a tiny object in the usual sense, but a localized event within a broader pattern. A moment where something happens and then fades. As the photon continues its silent connection across the cosmos, this idea becomes more meaningful. It is not a tiny object traveling through space in the way we might imagine. It is a kind of event, one that begins in the early universe and ends when its energy is absorbed. Everything in between is part of that connection, part of the pattern, part of the unfolding relationship between light and the universe it moves through. And as we move forward, this idea will deepen even further, because we will begin to see that light does not require a medium to travel through. It is not carried by something else. It is, in a sense, self-sustaining, a movement that exists on its own. And from that realization, a new picture of reality will begin to emerge, one where everything, not just light, may be understood as patterns within something deeper, something continuous, something underlying everything we see. There is a quiet moment in the story of light when something unexpected begins to reveal itself. Up until now, light has been allowed to remain a little mysterious. It spreads like a wave, it arrives like a particle, it bends, overlaps, and yet also appears in precise localized moments. And it is tempting at this point to imagine that perhaps light is simply a very smooth flow of energy, something continuous, like a stream that never breaks. But then, careful observation begins to suggest otherwise. Imagine for a moment a gentle beam of light falling onto a smooth metal surface. Nothing dramatic, just light arriving, touching the surface as it always does. Now imagine watching very closely, closer than the eye can normally see, paying attention not to the light itself, but to what happens within the metal. Something surprising begins to occur. Tiny particles inside the metal, electrons, are released. They are pushed out, as though something has given them just enough energy to escape. At first, this might not seem unusual. Light carries energy after all. It feels natural that shining light on something might cause a reaction, but the details are what make this moment so important. If light were purely a smooth, continuous flow, then increasing its brightness, making it more intense, should gradually increase the energy delivered. It should be possible to build up energy slowly, like filling a cup drop by drop, until eventually something happens. But that is not what is observed. Instead, the electrons are only released if the light has a certain character, a certain sharpness in its rhythm. If the light is too gentle, too low in its frequency, no amount of brightness will cause the electrons to leave. You can shine a brighter and brighter light, but if its rhythm is too slow, nothing happens. And then, with a different kind of light, one with a faster, more energetic rhythm, the electrons are released instantly, not gradually, not after waiting, immediately. This is where the picture begins to shift. It suggests that light does not deliver its energy in a smooth, continuous way. Instead, it arrives in small, distinct portions, not a steady stream, but something more like individual drops. A helpful way to feel this is to imagine standing in light rain. Each drop lands separately. Each one carries a small amount of energy. If the drops are too gentle, they do not have enough force to move anything. But if each drop carries enough energy, even a single one can make an impact. Light behaves in a similar way. It does not simply wash over a surface. It arrives in tiny packets, each one carrying a specific amount of energy, and if a single packet carries enough energy, it can release an electron immediately, without needing to build up over time. This was a subtle but profound shift in understanding, because it meant that light could no longer be thought of as purely continuous. It had a kind of granularity, a structure made of small, indivisible portions. These portions are what we call photons, and our photon, the one we've been following since the early universe, is one such packet. Not a fragment broken off from something larger, but a complete unit of light. It carries energy, it arrives as a whole, and when it interacts, when it is finally absorbed, it does so all at once. There is no half arrival, no gradual transfer. The interaction is complete in a single moment. This idea connects beautifully with everything we have seen so far. Our photon, travelling across billions of years from our perspective, does not slowly fade into its destination. It does not stretch out over time as it arrives. It completes its connection in a single event, a single transfer, a single moment where its energy is given. And this moment is not determined by how long it has travelled or how much time has passed, but by the nature of the photon itself. Each photon carries a specific amount of energy, shaped by its internal rhythm, by how tightly or loosely its pattern is arranged. Faster rhythms carry more energy. Slower rhythms carry less. But each photon is complete in itself. It does not need to accumulate. It does not need to wait. This is why, in the earlier example, increasing the brightness of a gentle light does not cause electrons to be released. You're sending more photons, but each one is still too soft, too low in energy to make the difference. Only when each individual photon carries enough energy does the interaction occur, and when it does, it happens instantly. This realization begins to reshape how we think about light. It is not just a wave spreading across space, it is also a collection of individual events, each one complete, each one distinct. And yet, this does not replace the wave picture. It adds to it. Because as we've seen, light still spreads, interferes, and behaves like a wave when not being observed in a specific way. So now, the picture becomes richer, more layered. Light is both a pattern that extends across space, and a set of discrete arrivals that occur in single moments. It is both continuous and granular, both spread out and localized, and our photon carries both of these aspects at once. As it moves through the universe, it behaves like a wave, stretching, bending, following the shape of space. But when it finally arrives, when it reaches a surface, a detector, or an eye, it becomes something precise, a single event, a single interaction, a single moment where energy is transferred and the connection is complete. This is where the story of light begins to feel less like a puzzle to be solved and more like a deeper structure to be understood. It is not that light switches between being a wave and being a particle. It is that our ways of describing it are only partial views of something more subtle, and that subtlety is what begins to open the door to a new kind of understanding. Because if light comes in packets, if it arrives in these small complete units, then perhaps everything at the smaller scales behaves in a similar way. Perhaps the universe itself is built not from continuous substances, but from interactions, from events, from moments where something is exchanged, transferred, or connected. And if that is true, then our photon is not just a traveller, or even just a messenger. It is an event waiting to happen, a connection waiting to be completed. And somewhere ahead, that completion still waits, quietly, inevitably, at the end of a journey that, from its own perspective, has never taken any time at all. There was a time when it seemed natural to believe that everything needed something to move through. Waves in water needed water, sound needed air. Even the motion of objects felt tied to the space around them, as though movement required a kind of background to exist within. So when people began to think about light as a wave, a quiet assumption followed. If light is a wave, then what is it waving in? What is the medium that carries it? At first, this question felt simple. There must be something invisible perhaps, filling all of space, a subtle substance through which light could ripple, just as waves move across the surface of a pond. This imagined medium was thought to be everywhere, stretching across the universe, gently supporting the motion of light. And for a while, this idea seemed reasonable. After all, every wave we experience in daily life requires something to move through. Water waves need water. Sound waves need air. It felt almost inevitable that light too must rely on something similar. But as experiments became more precise, something unexpected began to appear. No matter how carefully scientists looked, they could not find any trace of such a medium. There was no hidden substance filling space, no gentle background carrying the wave. Light moved through what appeared to be emptiness, and it moved perfectly well. This realization did not arrive all at once. It unfolded gradually through careful observation and quiet persistence. Measurements were made, refined, repeated, and each time the same conclusion emerged. Light does not need anything to travel through. It does not rely on a medium. It is, in some sense, self-sustaining. To understand this, it helps to shift the way we think about waves. When we imagine waves in water, we picture the water moving up and down, carrying the wave along. The wave is something happening to the water, but light is different. It is not something happening to a substance. It is something happening within space itself. A helpful way to feel this is to imagine a pattern that sustains itself, not because it is carried by something else, but because its own structure allows it to continue. Think of a pair of gentle oscillations, each one supporting the other. As one rises, it encourages the other to change, and as that one changes, it supports the first in return. A quiet exchange, repeating, sustaining the motion without needing anything external. This is a soft way to approach a deeper idea. Light can be thought of as a kind of self-sustaining pattern, an interplay between two aspects that continuously generate one another as they move forward. It is not carried by space. It is a movement within space. This may feel abstract at first, but it becomes more natural if we let go of the need to picture light as a thing moving through something. Instead, we can begin to see it as a process, a dynamic pattern that exists on its own. This idea reshapes something fundamental. It tells us that empty space is not truly empty in the way we might imagine. It is not just a void where things happen. It has properties, subtle, underlying characteristics that allow patterns like light to exist and propagate. Space is not a passive background. It is an active stage, and light is one of the patterns that can move across it without needing any additional support. As our photon continues its silent connection, this idea becomes more meaningful because the photon is not being carried along by anything. It is not riding on a wave in a medium. It is the wave, or more precisely, it is the smallest complete expression of that wave-like pattern, a single, self-contained unit of this ongoing motion. And this connects beautifully with what we discovered earlier. The photon is both spread out and localized. It behaves like a wave as it moves, and like a packet when it interacts. And now we see that this wave does not belong to any underlying substance. It is part of the fabric of space itself. This realization opens the door to a deeper question. If light is a pattern that exists within space and does not require a medium, then what is space made of? What is this fabric that allows such patterns to exist? Is it truly empty? Or is it something more subtle, something that we do not directly see, but that underlies everything? These questions begin to guide us toward a new way of thinking, one where the focus shifts away from objects, solid things moving through space, and toward patterns, interactions, and fields. The idea that what we call particles might not be tiny objects in the usual sense, but localized expressions of something more continuous, something that exists everywhere, something that can ripple, shift, and give rise to what we perceive as individual entities. As we follow this line of thought, the photon becomes less like a tiny object traveling through the universe and more like a moment within a larger ongoing pattern, a ripple that begins in one place and is completed in another. And this ripple does not need a medium. It does not need support. It exists because the underlying structure of space allows it to exist. This is where the story begins to deepen again. Because once we accept that light is not moving through something, but is itself a movement within space, we begin to see that perhaps everything we observe might share this quality. Perhaps what we call matter, what feels solid and stable, is also made of patterns. Patterns that appear stable from our perspective, but are at a deeper level dynamic and continuous. And if that is true, then the distinction between things and processes begins to soften. The universe becomes less like a collection of objects and more like a flowing structure of interactions. And within that structure, our photon continues its quiet role, not as a traveller carried along by a hidden medium, but as a self-sustaining pattern, connecting two distant moments without ever experiencing the time in between. As this idea settles, the nature of light begins to feel both simpler and more profound. It does not need a path laid out for it. It creates its own path through the structure of space, and in doing so, it reveals something deeper about the universe itself, that beneath everything we see, there may be something continuous, something underlying, something that allows patterns to exist and move without needing anything else. And from this realization, a new picture begins to form, one where light is not just a wave or a particle, but a ripple in something deeper, a ripple that hints at the true nature of reality. As the picture of light becomes softer, less tied to familiar categories, something even deeper begins to take shape. Up until now, it has still been possible to imagine the universe as a collection of things, small things perhaps, invisible things, but still things, particles moving through space, interacting, forming structures, building everything we see. But what if that picture is only a surface view? What if, beneath it, something more continuous is quietly present? To feel this idea, it helps to return to a simple image. Imagine the surface of a calm lake. At first glance, you might focus on the ripples, the small waves that move across the surface. Each ripple has a shape, a size, a direction. You can follow it with your eyes, watch it rise and fall, move outward and fade. It is tempting to think of each ripple as a separate thing, but the ripple is not separate from the water. It is not an object travelling across the lake. It is a pattern, a movement within the water itself. The water is what exists continuously. The ripple is how that existence expresses itself in a particular place, at a particular moment. Now, gently carry this image into something much deeper. What if the universe is not made of tiny objects moving through empty space, but of continuous fields, subtle underlying presences that exist everywhere? And what we call particles are simply ripples in those fields, not things, but events. Localized patterns that appear, interact, and fade. This is one of the quiet insights that begins to emerge from modern physics. Instead of imagining particles as tiny solid points, we begin to see them as excitations, small disturbances in a field that extends throughout all of space. The field is always there. The particle is what happens when the field is disturbed in a particular way. In this picture, the photon becomes something very different from what we might have first imagined. It is not a tiny object flying through the universe. It is a ripple in an underlying field, a brief, localized expression of something that exists everywhere. And this ripple begins at one moment and is completed at another. Between those two moments, from our perspective, we see a path. We imagine motion, distance, time passing. But from a deeper point of view, it is not a thing travelling. It is a connection between two events within the same underlying field. This brings us back gently to something we sensed at the very beginning. The photon does not experience time. It does not carry a clock. It does not move through moments the way we do. Because it is not a separate object moving through a timeline. It is a pattern that connects 2 points within a larger structure. And that structure, the field, is always present, always continuous. As you sit with this idea, something begins to soften in how we think about reality. The distinction between something and nothing becomes less clear. Empty space is no longer truly empty. It is filled with these underlying fields, even when no ripples are present. And particles are no longer tiny independent objects. They are moments, temporary patterns within something deeper. It is like watching waves on the ocean at night. You might see a crest rise, catch the light, and then disappear. Another forms nearby, then fades. Each one feels like an individual event, something separate, but all of them are expressions of the same ocean. The ocean is what remains. The waves are what appear and vanish. In the same way, the universe may be less like a collection of objects and more like a continuous presence, constantly forming and reforming patterns within itself. And our photon is one such pattern, a ripple that begins in the early universe, shaped by everything it passes through and completed when its energy is absorbed. It is not a thing that persists unchanged across time. It is an event that connects 2 moments. Everything in between, everything we imagine as its journey, is part of how we, from within time, interpret that connection. This way of seeing does not make the universe less real. If anything, it makes it feel more alive, more fluid, more interconnected. Because now, nothing exists entirely on its own. Every particle is part of a larger field. Every event is connected to the structure around it, and every interaction is a moment where patterns meet and influence one another. As the photon continues toward its destination, this understanding adds a new layer to its story. It is no longer just a messenger carrying information across space. It is part of the very fabric that makes such communication possible. It is a ripple in the underlying structure of reality, linking distant events without ever needing to move through time. And this idea begins to prepare us for something even more subtle. Because if particles are not fixed objects, and if their behavior depends on how they interact and are observed, then perhaps the paths they take are not fixed either. Perhaps at a deeper level there is not just one path but many possibilities, ways the ripple could unfold, ways the connection could be formed. And what we observe is only one of those possibilities becoming real. This is where the story begins to move into even quieter territory, where certainty softens, where paths become possibilities, and where the photon, still connecting its beginning and its end, may not be following a single, well-defined route at all, but something richer, something that includes many paths at once, gently converging into a single outcome. As our understanding of light deepens, something even more subtle begins to unfold. Up until now, it has been natural to imagine the photon moving along a path, a single line through space, a journey from one point to another. Even if that path bends gently with gravity, even if it stretches with the expansion of the universe, it still feels like a path, a continuous thread we can trace from beginning to end. But as we look more closely, this idea begins to soften, not disappear, but become less certain. Because at the smaller scales, the universe does not always behave as though there is only one way for something to happen. Instead, there seem to be many possibilities, many potential paths, and light, in its quiet way, seems to explore them all. This is not exploration in the way we usually think of it. Not a conscious searching, not a process unfolding step by step, but rather a deeper kind of possibility, one where all the ways something could happen are, in a sense, present together. To feel this idea, imagine standing at the beginning of a long landscape filled with countless possible roads. Some paths are straight, some curve gently, some twist and turn, wandering before reaching the destination. If you were to walk across this landscape, you would choose one path, follow it step by step and arrive at the end. But light does not behave in this way. Instead of choosing a single path and committing to it, it behaves as though every possible path is part of the story. Not equally, not all contributing in the same way, but all present, all influencing the final outcome. And when the photon finally arrives, when the connection is completed, it is as though all these possibilities have gently combined to produce a single, definite result, a single point of arrival, a single event. This idea can feel unusual at first because it does not match our everyday experience. We move through the world by choosing one path at a time. We follow a sequence of steps, one after another, building a journey that unfolds in time. But the photon does not experience time in this way, so it does not need to follow a path in the same sense. From its perspective, if we can still use that word gently, the beginning and the end are already connected. The path in between is not something it travels through step by step. It is part of the structure of the connection itself. And within that structure, all possible paths play a role. A helpful way to feel this is to imagine a surface covered in soft ripples. If you place a small disturbance at one point, the ripples spread outward in all directions. They do not choose a direction. They explore every possibility at once. Now imagine that those ripples are not just spreading across space, but are somehow connected to a destination. The ripples that align most naturally, those that reinforce each other, become stronger. The ones that conflict gently fade, and what remains is a pattern that reflects the combined influence of all possibilities. This is not exactly how light behaves, but it captures something of the feeling that the final outcome is not the result of a single path taken, but of many paths contributing together. As our photon moves through the universe, this idea adds a new layer to its story. It is not simply following one precise route. It is part of a deeper process in which many possible routes are woven together into a single connection. This does not mean that the photon is scattered or uncertain in a chaotic way. The outcome is still precise, still well defined. When the photon arrives, it arrives at a specific place, at a specific moment, transferring its energy in a single, complete event. But the way that outcome is formed is richer than a simple line through space. It is shaped by possibility, by the structure of all the ways the connection could have been made, and this helps explain something we've seen before: why light can interfere with itself, why patterns emerge even when photons are sent one at a time. Because the photon is not limited to a single fixed path. Its behavior reflects a deeper structure, one that includes many possibilities at once, and yet despite all this richness, something remains constant. The connection between the beginning and the end. The photon still links two events. It still carries energy from one moment to another. It still completes its journey in a single interaction. All of that remains simple. It is only the space in between, the way we imagine the journey, that becomes more complex, more layered, more subtle. As you let this idea settle, the notion of a path begins to feel less like a rigid line and more like a soft possibility, something that is not fixed in advance, but emerges as part of the connection itself. And this brings us gently back to something we've been circling around from the beginning, the idea that the photon does not truly travel in the way we imagine, that its journey, as we describe it, is a way of interpreting something deeper, a way of unfolding a connection across time, even though time itself is not experienced along that path. Because if all possible paths are part of the connection, and if no time passes for the photon, then what we call travel may not be what is happening at all. It may be something quieter, something more direct, a linking of two moments that from one perspective are separated by billions of years, and from another are already touching. And as we move toward the final part of this story, this idea will become clearer, because we will begin to see that the photon is not just following many paths. It is not just moving through space. It is something that does not need to move at all, something that simply connects. As we begin to settle into everything we've seen, the vast journey across the universe, the stretching of space, the shaping of light, the quiet unfolding of possibilities, something very simple begins to return. A question we asked at the very beginning: how can light travel for billions of years and yet experience no time? By now the answer no longer feels like a sharp contradiction. It feels like a quiet shift in perspective, because everything we have explored has been gently guiding us toward a different way of seeing what that journey really is. From our point of view, the story has been long and expansive. We have followed the photon from the early universe, through darkness, through the growing structure of galaxies, through bending space and shifting patterns. We've imagined it moving, drifting, crossing unimaginable distances over billions of years. But this entire unfolding, the sense of movement, of time passing, of a path being traced, is something we experience from within time. It belongs to our perspective, not to the photons, because for the photon there is no ticking clock, no sequence of moments, no before and after along its path. The moment it is released and the moment it is absorbed are not separated by a duration in the way we understand duration. They are connected directly. It is as though the entire journey is compressed, not squeezed smaller, but simply without any length in time at all. A connection without delay. This does not mean that the photon moves instantly, in the way we might imagine something jumping from one place to another. It means that the idea of movement through time does not apply in the same way, because movement, as we experience it, depends on time unfolding, and for light, that unfolding does not exist. A helpful way to feel this is to imagine two distant points, connected by a thread. From a distance, the thread appears long. You can trace it, follow its length, see how far it stretches. But if you could somehow step outside of that perspective, if you could look at the connection without the dimension of time, the beginning and the end would not feel separated in the same way. They would simply be linked. This is closer to how light behaves. The photon is not a traveller moving along the thread. It is the thread, a connection between two events. Everything we have called its journey, the billions of years, the vast distances, the evolving universe, is how that connection appears when we describe it from within time. But the photon itself does not go through those moments. it simply connects them. This is why the idea of a photon's perspective must be handled gently. It is not that the photon experiences everything instantly in the way a mind might perceive an instant. It is that there is no experience at all, no passage, no duration. And so, the beginning and the end are not separated by time in the way they are for us. They are simply part of the same event. This realization changes the feeling of the story. What once seemed like a long journey begins to feel like something quieter, more direct. Not a process unfolding step by step, but a connection that exists all at once. And yet from our side, the richness of that journey remains. We still see the expansion of the universe. We still observe the formation of galaxies, the bending of light, the subtle imprints carried along the way. All of that is real. All of it is meaningful. But it belongs to our way of unfolding the connection, to our way of experiencing time. The photon, meanwhile, remains outside of that unfolding. Not outside of the universe, but outside of time as we experience it. And this brings us back to something we began to sense earlier, that the photon is not truly a thing moving through space. It is an event, a beginning and an ending, connected across the structure of space-time. Everything in between is part of how we interpret that connection. As you sit with this idea, something begins to soften. The distinction between motion and stillness, between distance and closeness, between past and present, they begin to blur just slightly. Because if light connects distant moments without experiencing time, then the separation between those moments is not as absolute as it seems. The past is not simply gone, it is still arriving. Every photon that reaches us carries with it a connection to another time, another place. Not as a memory stored somewhere, but as a direct link, an event that is only completed when it is received. And in that sense, the universe is not something that happened and is now over. It is something that is still unfolding, still connecting, still arriving. Our photon, which began its connection in the early universe, is still part of that unfolding, and its journey, if we can still call it that, is not something that happened long ago. It is something that is happening when it reaches its destination, when it is absorbed, when its energy is transferred, when the connection is complete. This is where the story begins to draw inward again, because that destination is no longer distant, it is approaching. The photon is nearing the moment where its connection will be fulfilled, and when that moment arrives, something remarkable will happen. Not just in the photon, but in what it becomes, because light does not simply end when it is absorbed. It transforms, it becomes something new, a signal, a measurement, a piece of understanding, and in that transformation the story of the photon, this quiet connection across the universe, will become part of something much closer, something immediate, something human. And so, after everything we have followed, after the long unfolding of the universe, the quiet drift through darkness, the shaping of space, the subtle fingerprints left along the way, we arrive at a moment that is both very small and very profound. The photon reaches its destination, not with a sound, not with a visible arrival, just a quiet interaction. It touches something, perhaps the polished surface of a telescope mirror floating far above the Earth, perhaps a finely tuned sensor waiting in stillness, designed to capture even the faintest traces of light. Or perhaps, in a more intimate way, it reaches the delicate cells within an eye, tiny structures that respond to light and begin the process of seeing. In that instant, everything changes. The photon, which has carried its energy across the universe, does not continue beyond this point. It does not pass through. It does not linger. It is absorbed. Its energy is transferred. And the photon itself, this ripple, this connection, comes to an end. But this ending is not a disappearance, it is transformation. Because as the photon's energy is absorbed, it becomes something else, a signal. Inside a detector, that energy might release an electron, creating a tiny change, so small it would be invisible without careful amplification. That change becomes part of a larger pattern, a stream of signals that can be recorded, measured, and interpreted. Inside an eye, the process is even more subtle. The photon's energy triggers a response in a light-sensitive molecule, setting off a chain of events that travels through cells and into the brain. And somewhere along that chain, the energy of that photon becomes something we recognize. An image, a point of light, a fragment of a scene. In both cases, the photon is no longer what it was. It has become information, and from that information, meaning begins to emerge. This is the quiet completion of the connection. The photon began as a ripple in the early universe, a small expression of energy released when the cosmos first became transparent. It moved, or rather connected across space, shaped gently by everything it passed through. And now, at the moment of absorption, that connection is fulfilled. The beginning and the end meet. And in that meeting, something new is created. Understanding. When we observe distant light through a telescope, we are not simply detecting energy. We are reading a story, one written in the subtle details carried by that light. We reconstruct images of galaxies, maps of cosmic structure, traces of the early universe. We take something that has travelled, something that has connected, and we turn it into knowledge, and that knowledge becomes part of us. The photon does not know where it will arrive. It does not know that its energy will become part of a thought, part of a moment of awareness, part of a quiet understanding of the universe. And yet, that is what happens. The universe, through light, becomes visible, and through visibility it becomes knowable. This is where the story circles back in a gentle way, because from the beginning, we have been following a single photon, a tiny piece of light, born in the early universe, connecting distant moments across space. But now we see that its story does not end when it is absorbed. It continues in another form, in the data recorded by instruments, in the images constructed by scientists, in the ideas formed within the mind, and perhaps even now in the quiet awareness you feel as you listen. The photon's journey becomes part of your understanding, and in that sense the connection extends further, from the early universe to a telescope, to a signal, to a thought, a continuous chain, not of movement through time, but of transformation. Light becomes information, information becomes meaning, and meaning becomes experience. This is the quiet miracle of light. It does not simply illuminate the world, it connects it. It brings distant moments into the present. It allows the past to arrive, not as a memory stored somewhere, but as something real, something immediate. And it does all of this without ever experiencing time itself. The photon does not wait, it does not age, it does not travel in the way we understand travel, it simply connects. And in that connection, the universe reveals itself. As you let this settle, the story softens. The vast distances, the billions of years, the complexity of physics, they begin to feel less overwhelming and more like a gentle unfolding of something simple, a connection between moments, a thread of light linking the beginning and the end, and you are part of that connection. Because every time you see, every time light reaches your eyes, every time you become aware of something illuminated, you're participating in this process. You're where the journey of light becomes meaning. You're where the universe is seen. And so, we come to the end of tonight's exploration. Not with a conclusion that closes the story, but with a quiet sense that the story continues, carried in every photon, in every moment of light, in every connection that is still being made across the universe, whether your eyes are still open or you're already drifting somewhere between waking and dreaming. Thank you for being part of this gentle journey. If you'd like to return for more quiet explorations, you are always welcome here. For now, the universe continues its silent unfolding. Light continues its timeless connections, and somewhere, even now, another photon is completing its journey. By arriving softly into awareness, sleep peacefully wherever and whenever you may be.